Okay, dia dah start recording lah. Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In today's topic, we are going to talk about fundamentals of robotics and automation. Okay, uh, in learning about this subject, you can also refer to my book on robotics and automation that I already upload into the Google Classroom. So we are focusing on the first topic, which is the fundamentals of robotic and automation. Okay, so this is an era of transformation. You have learned, you have heard about the industry 4.0. Now people are talking about industry 5.0. Everything is 4.0. Everything. Everyone is talking about 4.0 now. Okay, this is an era of transformation. Robotics and automation are creating a new era affecting sectors from home service and agriculture. Okay, technology integration, sophisticated technologies and innovative mechanism to enhance human interaction, autonomy and efficiency. Okay, development of systems that are more autonomous, efficient and intelligent, innovative mechanism, exploration of mechanism like heterogeneous attention fusion, mission-based architecture for better service and agricultural practice, and revolutionizing daily life, showcase potential to change everyday tasks and professional operation. Okay, you can see here, this is what we are going to talk about automation. The automation in general, for the purpose of this subject, we are talking about automation in factories. Okay, but if we take it to the broadly, automation also involve things that uh, things that beyond the automation in the factory, which is our daily life, also agriculture and everything. Okay, you can see this illustration of the picture that I use ChatGPT to illustrate to you. You can see the robot like a human figure robot. And this is artist impression lah about it. Nowadays, for the latest robot, we can see the robot from Boston Dynamics in America, USA. It's so advanced. There is a robot like a human, and also robot like a dog, kan? Okay. There is a future, maybe in near future, we can see that kind of robot in our life. But in terms of robot also, we can see in our daily life, like our washing machine, our vacuum cleaner, our TV, and everything. That is called also can loosely defined as a robot also. Kan? Uh, it help us in agriculture also. People in agriculture sector, they use a machine, machine that will help them to for agriculture purpose, picking up the fruits and everything. Okay, or we also use the robot for our daily life in cleaning and cleaning household and everything. Nowadays, in 2004, of course, we do not see this kind of human-like robot yet, but in near future, maybe we can see some of them in our near future lah, in our lifetime. Okay, so um, concerning about robots, there are many movies. Okay, many movies. You can imagine many movies like the Terminator, like the one that Will Smith play. Many movies talk about robot and they give back interpretation about the robot lah. We do not know yet, kan? We do not know yet. Maybe the robot have the thinking like a human. That time it will be dangerous lah. But as long as they have limited thinking of themselves, robot the way of the thinking, they don't have the what in our Malaysia culture is we call the roh. They don't have the roh, kan, roh jasad dan sebagainya. Jadi I think it is okay lah, kan? Okay, So that is my opinion right now lah, kan. Okay. So we can see innovation in robotics for home and agriculture. Okay, just for slightly deviate from our subject, which is automation in the factory. So you can see advancements, advanced mechanism transformation, significant advancements or in robotic and automation are transforming home service and agriculture. Okay, heterogeneous attention fusion by Zhu et al. 2034 introduced a mechanism for enhanced scene classification in home service robot, improving interaction and understanding. What is scene classification? Okay, uh, imagine your home now. You're in your room right now. Okay, the robot can identify which is the bathroom, which is the hall room, which is the kitchen and everything. Okay, this is called scene classification lah. And if you this is called home service robot. Okay, uh, there is a one kind of small vacuum cleaner, kan? The vacuum cleaner, you put on the floor and then it walks. It crawl all over our home. Okay, that that kind of vacuum cleaner, when it have scene classification feature, it can identify where is the bathroom, where is the hall room, where is the kitchen and everything. Okay, so this is called scene classification lah. Okay, vision-based agriculture architecture for agriculture. So Paul et al. 2034 developed an architecture that streamline fruit picking through home robot classification, collaboration using image processing and machine learning. Okay, this is developed by Paul, meaning that the robot can pick. Okay, the robot can pick fruits. Okay, we also know that not every fruits are ripe enough. Kan? Okay, they don't simply pick rotten fruits. Of course, they are rotten fruits. Okay, so you can imagine the robot travel throughout the place like this illustrated in the picture here, also illustrated in the picture here. The robot travel, and when it travel, it can identify which fruits are rotten, which fruits are not rotten, which fruits are ready to take. Then the robot will take only the good one. Kan? You can imagine like that lah. Kan? And number 4, enhancing human-robot interaction. Both studies aim to improve the efficiency and efficacy of robot in dynamic environment and challenging tasks. Like we can see the two major industries in major players in the world right now, Samsung and Apple. Apple have Siri, Samsung has Bixby. Bixby. Okay, so they can talk to each other. Okay, they can talk to each other. They can interact to each other. We can interact with the Siri. For Samsung users, we can interact to the Bixby. Also for the Google user, you can interact with the Google punya platform, kan? And then we can ask them to do anything with our handset lah, kan? Okay, the scheduling and everything. Imagine it is a robot, then we can ask the robot to do anything that we want, kan? Okay, so robotic evolution in the modern era. Okay, this is evolution. Since I get the all this information from the latest one, so I present to you the latest information lah. This evolution, meaning that evolution we must talk from the old generation, like the introduction of industrial revolution and everything. So introduction of the flight, introduction of the robot, computer and everything back in 100 years, 150 years back kan, this evolution. Okay, now I'm talking about now 2024 punya evolution. Okay, heterogeneous attention fusion, Zhu and all, enhanced scene classification like I discussed before. Robotic advancement like Paul et al. Developed vision-based architecture. Okay. Now the new thing is digital twin and digital robotic. Mali project. Okay. Demonstrate the use of digital twin for improved navigation and task planning in retail robot. Okay. Then right at all, introduce reconfigurable soft robot, pushing the boundaries with robot with complex and non-linear material. And then dual arm robotic system, the Agostino, explore the cable suspended robot for safe operation in hazardous environment. Okay, this is among the things that people use now. The new things that you may hear, the new term you may hear is digital twin. Okay, digital twin, which is can imagine like illustrated by this picture. There is a human operating. Okay, the robot is in the in the real environment. You are in the office. You control the robot from your office. Okay, this is called like digital twin lah. Kan? Okay, twin everything. Okay. Evolution of autonomous system. Okay, we are going inside our subject, which is subject automation. Okay, when we dealing about automation, we are dealing with autonomous system. We see the robot must be moving. Okay, the robot must be moving and everything. Okay, we are talking about moving robot, conveyor and everything. This is called moving. Also stationary robot, which is also have things that move like their arm, their legs and everything. Okay. So machine design for independent operation across various sector. Okay, digital foundation, which is combine robotics, AI, artificial intelligence, machine learning for decision making and task execution. And innovation, the cognitive robotics in manufacturing, precision agriculture with mobile robot, aerial robot and construction, and AI in food processing. Okay, application across domain for manufacturing, agriculture, construction and service robot. Human robot collaboration focus on safe, effective and intuitive system for human-centric workflow. Okay, so you can see here, people aim to make robot. The robot can be used in many sector. One robot can be used in many sector. The best example right now, for in 2004 right now, is from the robot from Boston Dynamics in America. Kan? We have seen all the videos. We can see the robot can be used in many applications. It's a human-like robot. Even the robot can be used in military also. They can shoot the bullets and shoot the pistol and everything. You can Google Boston Dynamics robot. As I right now know, they are the leading lah in the world right now lah. Okay. We take them as example. Right now, 2024. Future, maybe there are many new players like that. Okay. When I give example right now, I want to imagine that kind of robot. Okay, that robot can be used for multi-purpose. Okay, can be used for multi-purpose. It's kind of not a dedicated robot, meaning that the robot is designed for your own factory. Now, it's okay, kan? But what the slide is talking about, the robot that can be used in many fields. Okay, can become an assistant for us, kan? Okay. So, okay, you can see this illustration here lah, kan? Okay, computer integrated robotics, revolutionizing automation. Okay, era of computational intelligence in robotics, transition from mechanical operation to autonomous decision making, meaning that we can see what we learned in mechanical subject. I believe every one of you from mechanical, I remember one student is from computer kan. Okay. About history of mechanical, back into 150 years ago, when people introduce steam engine, everything at that time is computer, is mechanical now, kan? Everything is mechanical. Okay. Um, uh, before World War One, before World War Two, there is evolution of computer. Back in 1940s, everything. When the computer arrived in this world, okay, people are integrating mechanical with computer, computer programming, everything. Now we can see the advances of artificial intelligence and everything. You can see the robot uh, will be able to behave like a human. They think as a human, everything lah. So uh, maybe at one day human programmers put a stop to them. If a robot can become thinking like a human brain, maybe it's positive, maybe it's not positive, maybe it's a negative thing. But we will see in the future lah. I I'm confident we will see that in our lifetime. In our lifetime, okay. Uh, So foundation principle, core concept behind the integration of computing and robotics, historical evolution from early automation to intelligent adaptable system, technological advancements like path planning, collision avoidance, and control of continuum robot. Okay. So we're talking about automation. You can imagine the factory. There are many tables, many conveyor in the factory, in the typical factory, like illustrated in this picture here, kan? Okay, so when robot are moving, of course, like a car, like moving, we become accident, kan? Of course, like our every day we heard about accident, car accident, motorcycle accident, everything. So how robot can must avoid it? Okay, how the robot can avoid accident. So this is path planning, collision of it, avoidance, and everything. Control of continuous robot, meaning that how can we control all this robot with one server and everything, kan? These are things that people are in doing research, ongoing research, never-ending research about this, kan? The impact on industry, enhancement in robotic functionality and manufacturing process. Okay, so the evolution of computer integrated robot. So historical progression, like I said before, it is an advancement from mechanical replication to intelligent autonomous system. Key development is path planning and collision avoidance with novel algorithm. Advances in continuous robot will enhance flexibility and control. Okay, significant research by Zhu et al. Rule guided lazy PRM for gantry working robot and research by Barr et al. 2024 differential kinematics in tendon driven continuum robotics. Okay, so the impact overcoming complex environmental challenges, paving the way for innovative application. Okay, so you can see here, you can see illustrated by this picture here. Okay, the evolution of robot lah, kan? Yeah, this is an illustration lah, meaning that from beginning of the robot is purely mechanical until right now, robot is more advanced. Okay, so the like I said before, path planning and collision avoidance is an important thing lah. We don't want the robots to collide. Okay, to collide with the robot and also to collide with a human lah. Okay, transforming manufacturing with computer integrated robot. Okay, there are revolution in manufacturing, automation and flexibility through robotics and computational intelligence. Okay, key application here is automated assembly line, quality control with advanced vision system, material handling and inspection, digital twin and virtual optimization. Okay, there is a subject in material handling. Later on, I will make a book on material handling itself. Okay. Okay, innovation and agriculture, vision-based architecture for human-robot collaboration, industry 4.5.0 and human-robot collaboration, dynamics aware application for safe interaction in shared workspace. Okay, advancement in augmented reality, risk assessment in social technical robotic manufacturing development. I want to make comments on industry 4.5.0. You have heard about industry 4.0, and now you heard about you hear about industry 5.0. Okay, what is the difference between 4.0 and 5.0? Okay, 4.0 is integration of robotics and machines into the into the our machine, meaning that you can imagine any kind of machine. uh, for the simplest one that you can imagine is our headset lah. Our headset is also a machine, kan? It's also a computer processing. Then there are many camera, internet of things, sensor, Wi-Fi, all in our headset, all in our laptop and everything, kan? Okay, this is uh, um, this is an industry 4.0 lah. But what is the difference between 4.0 and 5.0? 5.0 is introduction of element of artificial intelligence inside this. Okay, so if you can remember Samsung handset S24, it says that it has artificial intelligence element in the telephone. Okay, so those who buy Samsung S24 handset, okay, they can access to artificial intelligence artificial intelligence tools inside the handset, meaning that the handset can link lah to what we want. Okay, making our life easier, kan? Okay, there is a level of smartphone. Okay, uh, of course this technology will be replicated by Apple and all other industry player in phone, meaning that it started with the telephone because it is easy. It's easy, but you can expect in the future, your machine have the brain of its own. Okay, artificial intelligence can be integrated with the machine. What kind of machine that I'm talking about? Like the CNC machines, the what machine that you can imagine in the typical factory. As I remember, all of you have not work yet in the industry. Maybe you can imagine. Maybe it's quite difficult for you to imagine the industrial environment. Maybe you can remember what you have learned in your practical intern years, when you doing intern in your factory. You imagine all the machines in your factory when you are doing intern a few years back. Okay, that machine have artificial intelligence element in their machine. Okay, so that machine can think of its own. Okay, so it will be very helpful. Okay, so the last one is advancements of augmented reality, ARD, augmented reality. uh, uh, Apple Vision. Okay, the Apple company have have introduced Apple Vision. Okay, meaning that you can put the Googles. Okay, and then inside the headset you can see everything, technically everything. That people are excited to use it. I have seen a lot of videos, uh, 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 and it's expensive lah. If you coming to Malaysia, 10,000 ringgit like that lah. Okay, if we have the budget, we can buy it. Okay, can buy it. It become the augmented reality. If you can Google, when you Google, you Google Apple Vision. This is the most advanced augmented reality for the time being. Okay, so this is illustration. Okay, AI and machine learning. revolutioning robotics. Okay, conversion of artificial intelligence and machine learning, autonomous learning, and decision making robot, neural network, foundation of advanced robotics, enabling adaptability, efficient, reinforcement learning, automation from environmental feedback, advancing task scheduling and control, autonomous decision making, machine learning algorithm enhance robot performance across domain, application from industrial robotics to AI, cyber enhance. Okay. I know one person among you is background is computer kan. I think Renga is computer background I think. Is it right I think but every one of you is mechanical background. So in our subject, we do not learn directly about this. We know about this, but your friend in computer, they learn to how to program about this. Okay, so they can understand better what I'm talking about lah. Okay, everything that I'm talking here involve programming. Okay, people have to sit in front of the computer, do the programming and everything. Kan? Before the element of artificial intelligence, they have the machine learning. What is the difference between machine learning and a reinforcement learning? Okay, machine learning is operated by the machine itself. Okay, meaning that we give the task, we give the everything, we give the information, and then the um, I have searched for it. Okay, broader category attention. Because we develop the algorithm and statistical model and enable computer to perform specific tasks without using explicit instruction. Okay, they rely on pattern and inference derived from data. Machine learning encompass variety of techniques and algorithm, including supervised learning, unsupervised learning, and semi-supervised learning. Okay, so we input the computer to the computer all the pattern or the algorithm and the machine we want the machine to think on its own. Okay, we want the machine to think on its own. Okay, how about reinforcement learning? Reinforcement learning, you can imagine that you yourself, okay, myself, yourself, when we learn how to walk. Okay, back in our toddler days lah. Also you can see your your niece, your anak menakan, anak saudara, everything. They learn how to walk. Okay, like that lah. When they learn how to walk, the baby, they learn how to walk, they fall down and they they rise and they walk again and fall down, walk again and fall down. This is called reinforcement learning. Can you imagine the baby kan? Okay, so what I mean is for robotics, okay, we give tasks and then they learn from mistake lah, like the like robot that play chess. Okay, robot that do the outdoor work where there are uncertainties. Okay, uncertainties like robot that play basketball, robot that play football and everything. They learn from experience. Okay, this is called reinforcement learning lah. Okay, so this is an illustration. Okay, neural network in robotics, paradigm shift. Okay, core impact transition to intelligent, adaptable, and efficient robotic system, advanced path planning, enhancement in robotic safety and efficiency for complex environment, robot manipulation and manipulation and control, security of neural network, manufacturing assembly innovation, introduction of precision and efficiency with AI-enabled technology, space and beyond, advancing automation in challenging environments like space, the outer space now. Okay, so highlight from 5 researchers of from Zoo et al. Collision free path planning for country wedding robot. Of course, the country is above, so it will not collide lah, kan? But at all, controlling tendon driven continuous robot. What is tendon? Okay, the robot have a niche like this. Okay, the robot that you see the picture, the robot is jumping. Okay, they have the knees like our lah, like we, yeah. We human, we have knees, we have the arm, the siku, the lutut and everything. Okay, so uh, how to control the tendon? Okay, and Gonzalez et al. 2024 robot assisted computer vision for edge finishing. Okay, for mechanical student, you can imagine what is you have learned about machining. Okay, you learn about machining. The problem in machining when the edge they have become the burr and everything. So how to eliminate the burr to make it finishing a bit much better lah. Okay, Luted et al. 2024 and I enable cyber physical in orbit factory. Orbit, what this meaning by Luted et al. Is in orbit in outer space lah. Tarantos et al. 2004 dynamic navigation and facial expression recognition in robotics. Okay, so facial recognition, who the robot want to recognize? We as a human, we have many faces, like smiling face, like angry face. Okay, then everything. Okay, the robot can recognize and the robot can interact with that lah. Okay, so this is the illustration of it. Reinforcement learning impact on robotics. Okay, fundamental, yeah. Enhancing the autonomous system through maximize cumulative reward. Okay, multi-agent reinforced learning for collaborative robot tasks. Reinforced learning in controlling modular sound robot amidst uncertainties, overcoming disturbances. Okay, differential flatness based adaptive robot control for cyber navigation, and innovation in digital twin, synergies between reinforced learning and the technology for safer human robot collaboration. Okay, so this reinforced learning, the way that I read about it a little bit, meaning that robot also have reward system now. Like us, unless like I give example, like you see your anak menakan, you see your anak saudara walking, kan, and then when your anak saudara niece can walk, the mother give the ice cream, kan, the mother give the ice cream. Okay, the father give some toys because as reward to the toddler, to the baby, because baby can walk like that lah, kan. So the same goes to the reinforced learning. Okay, you can see somehow in the programming of itself, it have the give reward. Okay, meaning that the robot can learn lah. The robot can learn and give some reward, and then it's like that. Okay, so this is among the features. Okay, and the last slide, okay, is machine learning algorithm for autonomous robotic. The enhancement of machine in robotic machine algorithm for driving autonomous decision making, modular soft robotics. There are terms HTS for task allocation for performance optimization, comparative analysis to superiority in completion time, threshold balance and computational accuracy, efficiency, real-time scheduling, robotic perception, interaction, space exploration, and detective technology. Okay, this thing that you learn, this thing that is important thing in factory, because factory is playing with time. Okay, time is money. Okay, we learn time is money from our subjects in design for manufacture. If you learn design for manufacture subject, you can see the time money is in second now. Every second is money. Okay, so we want to save all the money. Okay, we want to save. We aim to complete our product in very minimal time. Okay, so this can be accomplished with the help of robot. Okay, of course human brain is very powerful than robot. Okay, the problem is human tend to fatigue. Okay, when we are working now. Okay, after 5 o'clock, we cannot concentrate there yet. Okay, we cannot concentrate anymore. Okay? We are thinking about eating, we are thinking about sleeping and everything. So this is limitation of the human, but human brain is more powerful than robot does. That is why human uh, goes to the programming to assist the robot lah, to help robot to assist human. Okay, about the path planning, completion time and everything, reduce computational efficiency and everything lah. This is why we have to use a robot lah, kan? Okay, so this is an illustration. Maybe what we can interpret with this, that uh, maybe we have to be aware lah, kan? Not to rely on the robot. Maybe the robot will make damage to us, like we see in many movies. Terminator by Arnold Schwarzenegger, kan? Many movies are talking about this. So we should be aware lah. Okay, I don't know what the picture hold for us, but I can see in our lifetime, 10 years, 15 years in the future, there will be revolution in robotics and everything. Okay, so that's all for my slides. Okay, that's all for my slide. You have question? Do you have question? Do you have question ke? Ada soalan ke ni? Renga ke? Chan Minyong, Adlin, Adiba, Shamini. Ada you have question?
No, Doctor.
Okay. So that's all for the today class. We meet again in Selasa, in Tuesday, inshallah at 9:15 at night. We talk about sensor. I just follow the book. I just followed the book that I already upload to you. We are talking, inshallah, we're talking about sensor and actuators. Okay, technological advances in robotics, which covers the sensor and actuators in robotics, the robotic computer vision, and human robot interaction. Okay, this is what I will cover in this Selasa class. Okay, I think that's all for now. Selamat berpuasa, selamat buka puasa dan sebagainya. Okay, so thank you very much. Okay, I stop recording and I will upload in my YouTube channel. Okay, okay, wait. Okay.
Thank you, Doctor.